Hi, my name is Mehmet Emre Andıran. I am a first year electrics and electronics student at Bilkent University. In this video, I am going to talk about my Physics 101 lab project titled The Effect of Mass on Free Fall. Free fall is the motion that takes place when an object at rest is released at a certain height above the Earth's surface due to gravity. The aim of this experiment is to observe that free fall is not dependent on mass. Free fall occurs due to gravity, and the magnitude of the gravitational force is dependent on mass. However, because of Newton's second law of motion, the mass of the objects cancel each other, so the acceleration the free-falling object has will be the same regardless of its mass. All in all, two objects with different masses dropped from the same height should land on the surface at the same time. Two objects sharing the same geometry with different masses will be dropped from the height of 2 meters, and the time it takes them to land will be measured using a 240 frames per second phone camera. This will be repeated 3 times per object. The average time it takes them to land will be calculated for each of them separately, and the difference of the acquired results will be compared to each other and the theoretical value using g equals 9.81 meters per second square. If we take the release point as the origin and downwards as the positive direction, our theoretical time equates to 0.639 seconds. By inspecting the high-speed footage for all 6 releases, we get these results. The average time for both objects was the same, with 0.638 seconds, and because of that, both objects shared an error percentage of 0.2%. Again, using this formula, accelerations of the first and second objects are found to be the same, with both of them sharing an acceleration with a magnitude of 9.83 meters per second square. The error percentages for the accelerations of both objects are again found to be 0.2%. In this experiment, I tried to observe the effect of mass in free fall motion. The expectation was that mass wouldn't affect the fall time, and that expectation was mostly met. In real life, the times should have been more, and the accelerations should have been less than the theoretical time and acceleration respectively, because of friction. However, the opposite was observed in this experiment. This shows that there were several mistakes in the setup of this experiment. One might be the misconsideration of the center of mass of the object, as the object had significantly more length than width, and I measured the distance from the top of the object, resulting in the center of mass being at a height less than 2 meters. Also, the gravitational acceleration might be slightly different than the one used in this experiment due to the location and the elevation of Ankara. The height of the object may have differed in each release because of human error, and the measurement of time using high-speed footage may contain errors as each frame was inspected by a human. All in all, this experiment shows that mass doesn't affect the time of free fall, as the average air times and accelerations are found to be the same with both objects.